in a 1974 book, and perhaps I will give the link to that book in the description. I found this circuit, and when you are a little bit acquainted with electronics, you will surely recognize this as a multivibrator circuit. Again, a multivibrator circuit. I'm very interested in that type of circuit, and then especially to get to pure waveforms in a very simple way. That did surely not work out. In that book of the 1970s, they advertised this as a circuit with which you could get all kinds of waveforms. They told about square waves, triangle waves, etc., etc. But the only waveform that I found looked like this. Perhaps interesting to tell, it works, and that's of course very important. And I added in that circuit, and that was not original in it, but anyway, in other circuits I found that kind of solution. I added here in the past 2 diodes, silicon diodes by the way, and in that way I could get, with a tiny capacitor here, say 4N7, so 4700 picofarad, I could get to the megahertz range, 1.5 megahertz or perhaps 1.6 or 2 megahertz, but the waveform was more or less not curable. So I left this circuit after many experiments, but I found one good application for it, and that is this minimum components alarm beeper. Good property of this circuit is that it always works. It works in a big voltage range between 1.2 volts and 18 volts and even higher, and I want to demonstrate it now. They told in that book it could get to 30 megacycles. I surely did not find that. So, circuit again, and I've made a table here to show how this circuit works with different input voltages. And of course it's a multivibrator, so the time dependent capacitor here plays also a role. It's now 10 microfarad, 2 4.7 microfarad capacitors in parallel, that's 10 microfarad. And here are the results of the voltage, the current that the circuit takes, and its output in terms of milliwatts. That is only an indication. I did not measure that precisely. Say it's what I have, say what I hear. That's the idea. Anyway, let's see and listen. This is the voltmeter, amperemeter, and here we have that speaker. When you want to get a good result, rendement, use a speaker with a certain diameter. Small speaker of course is not able to push much audio energy out anyway. So here's my voltage supply. Start now with a small voltage and let's listen and look at the scope. We start with the smallest voltage, 1.2 volts. The waveform, the frequency 1.1 kilohertz. Now we go to the second voltage of the table, that's 5 volt. Volts. It takes this current, that is 35 milliampere approximately, 35 here on the scale. So A higher voltage now, 9 volts here. Nine volts. The current that it takes. The waveform. So, waveform frequency 2.7 kilohertz. Higher voltage 12 volts. Takes more current. It's all in the table, by the way. So now I switch through. I erase the voltage without more comments about the current that the circuit takes. We are of course looking at the scope and the frequency. Waveform frequency 4.2 kilocycles. 14 volts could be interesting because a car battery, let's say a voltage related to a 12 volt lead acid car battery. .3 kilohertz, and the highest voltage 18. Of course I can go higher. Let me try it. So this is the highest voltage, 21 volts. And there is of course, and that's perhaps important to tell, a relation between, say, the level of irritation that this sound gives, and that's of course related to the frequency. The human ear is very sensitive in this frequency range, going from 1 kilohertz up to approximately 6 kilohertz. So these are sounds that you can hear. I shall stop it now. You can hear these sounds in this frequency band from quite far away. It's even possible that you hear that sound in this frequency band, and then especially around 4 kilocycles, say 10 meters away. That's also the reason for, say, using these two capacitors, or this capacitor of, in this case, 10 microfarad. Anyway, the circuit again. This was all. Thanks for watching. Hope it was a little bit interesting. There are many circuits of these kinds on the World Wide Web, beepers, etc., also made in many other ways. The table again. And the sound level is an indication that's also related to what I told, that the human ear is very sensitive in this frequency band. So for an alarm beeper, this is a good frequency band, and then especially from, say, 3 kilocycles to 5 kilocycles. Anyway, that was all. Wish you luck.